Good morning. Today we are going to talk about right triangle trig with application problems. So just a reminder, angle of elevation versus angle of depression. Remember that angle of elevation is above the line and angle of depression is below that horizontal line. So as an image here, your angle of elevation is this angle right here, where your angle of depression is this angle. But if you recall from first semester, we talked about parallel lines, which are your dotted lines there, being cut by a transversal, and angle 1 and angle 2 are actually alternate interior angles. And with our alternate interior angles theorem, we know that if we have two parallel lines, the alternate interior angles are congruent. So in reality, when you draw your triangle, that bottom angle is the same as that top angle. The bottom angle is usually the one that's inside of your triangle based on how you draw it. So whether it says angle of depression or angle of elevation, you can always put it in that bottom area. So let's do a problem. Okay, it says the Seattle Space Needle cast a 67-meter shadow. If the angle of elevation from the tip of the shadow to the top of the Space Needle is 70 degrees, how tall is the Space Needle round to the nearest meter? So if you think about it, the Seattle Space Needle is going to be that line right there. And your shadow is always the shadow that's on the ground. And then you can form what we would say is a right triangle, because your shadow is going to be perpendicular to the height of the Space Needle, and it says that it cast a 67-meter shadow, and it has an angle of elevation of 70 degrees. So your 67 is going to be right here, and your 70-degree angle is going to be right there. And we want to know the height of the Space Needle. So what we've done is we've made our right triangle, and now we have to think about SOHCAHTOA. So we have our opposite side and we have our adjacent side. So the trig function that uses O and A is our tangent. So we're going to have the tangent of 70 degrees is equal to your opposite, which is the height, over your adjacent, which is 67. And when we cross multiply here, we have 67 tangent of 70 is equal to h. And when we calculate that using our calculator, we find that h is 184.08. And because it says to round to the nearest meter is going to be 184 meters. And that is the height of the Space Needle. Now let's look at another example here. So it says a pilot flying at an altitude of 12,000 feet sights two airports directly in front of him. The angle of depression to airport A is 78 degrees and the angle of depression to airport B is 19 degrees. What is the distance between the two airports? So this one is a little bit more complex. Altitude means height. So our height is 12,000, but we have two airports. And airport A is at 78 degrees and airport B is at 19 degrees. So if we draw that diagram, and it is not going to be drawn to scale, I will tell you that. Okay, so this is going to be our 12,000. And that's the height of the airplane. And imagine the pilot is sitting at the top of that line, and it's looking out, and let's say here is airport A, and here is airport B. So his line of sight to airport A is right here, and the line of sight to airport B is right here. So when you think about that horizontal distance here, I'm going to change my color for a second. That is your angle of depression to airport A, and that is your angle of depression to airport B. But we talked that angle of depression and angle of elevation are actually alternate interior angles. So that angle is going to be the same as our top red angle, and that angle is going to be the same as our green. So this one is 19, whereas our red is 78. Now it's asking us to find the distance between the two airports, which means I want to find this distance here. And let's just label that as X. But in order to find that, we need to find we have a couple triangles here. We have, I'm going to label this as C and this as D. So we have triangle AC, let's highlight it, ACD, and we also have triangle BCD. And so what we need to do is we need to find the distance AC, and I'm going to label that as Y, and we want to find the distance of CB, and I'm going to label that as Z. And when I take and subtract Y from Z, I am going to find the distance between the two airports. So I'm going to scroll up here. Let's find our Y first. So when we think about our Y, we have this yellow triangle, and 78 degrees and is our angle, and then we have the side opposite of that, which is 12,000, and we need to find the adjacent side. So that is going to be using the tangent function. So I'm going to scroll up here. We're going to have the tangent of 78 is equal to 12,000 over Y. And when we cross multiply, we have Y times the tangent of 78 is equal to 12,000. And I need to scroll up a little bit more. We're going to divide by the tangent of 78 on both sides. And we end up with Y is, let's see here, 2550.78. 2550.7, or 68, sorry. Not 78, 68 feet. So that's our Y. And now we need to find Z. So if we go back and look at our diagram, we have the 19 degrees, and then the side opposite is 12,000, and the adjacent side is Z. So again, we're going to do tangent, but now it's going to be tangent of 19 instead of tangent of 78. So we have tangent of 19 is equal to 12,000 over Z. And then we cross multiply and we have Z times the tangent of 19 is equal to 12,000. And then we have to divide both sides by the tangent of 19. And we end up with Z is equal to 34,850.53 feet. And so if you recall from our diagram, if we take our Z answer and subtract our Y, we will get X, which is how we represented our distance between the two boats. So when I subtract our 34,850.53 and subtract our 2,550.68, I get 32,299.85 feet. So the distance between the two boats is almost 33,000, or almost 32,300, excuse me. And that is how you will use your trig to answer